And now we're going to roll into our first applied problem. So when you have a word problem, the first thing you're going to do, and this seems like a simple thing to say, but is you're going to read it. When you're reading it, I want you to identify what type of application you're solving. So in these word problems or these applications for chapter 1, there's going to be 3 types. So you're going to look at the question and be like, which type is it? And you're also going to identify what you're solving for. This is probably the most important thing. When you're reading the question, usually the last sentence will tell you what you're solving for, and then you're going to assign a variable. So let's just practice that with this first question. Let's just practice the first 2 steps. So this first question says, Maria and James are collecting stamps. Together, they have 3,240 stamps. Maria has 420 more stamps than James. How many stamps does each person have? Now, you're not going to know what type this is. I'm going to call this one of the totals type applications. But what I want you to do is look for what you're solving for. In this last sentence, it says, how many stamps does each person have? So we're solving for the number of stamps that Maria has and James have. Now, I get really lazy with what we call these are called like let statements. I get really lazy with them. I often just put Maria and James, and then I know that I'm finding the number of stamps for each of them. But you can be more particular and be like, okay, I'm finding the number of stamps for each person. Now, in chapter 1, you're only allowed a variable. We're allowed an x. So what we're going to do is try to express both of these things that we don't know in terms of x. These questions will always give you a sentence that tells you something about the number that one of them has in terms of the other. So for example here, Maria has, it's almost like the word is. Maria has 420 more stamps than James. So what I would do is let James be J. And I would say that Maria has 420 more stamps than James. So you can use an X here. I tend not to use X's in application questions because I want to use a variable that when I solve it, I'm like, oh, that's James, versus being like, who did I let be X again? I don't know. Okay, so that's your first 2 steps. Step number 1, reread it. We're going to identify this as a total application. And then we are going to assign our one variable. To do that, you're going to assign figure out what you're solving for. One of them is going to be assigned the variable, and then the other one you're going to write in terms of them. Now, I call these questions total questions because they'll give you this sentence. Together they have. Now, for this example, together they have 3,240 stamps. So the number of stamps that Maria has plus the number of stamps that James has will equal 3,240. Maria, we're letting be James plus 420, and James, we're letting just be J. That's it. That is step 3. So in step 3, you're going to write an equation in one variable. So we're going to use this information to set up an equation that we can then solve. To solve this, we're going to use the same way we've been solving every literal equation or every linear equation. Step number 1, simplify. I have 2j's plus 420 equal to 3,240. To get the j by itself, I have to get rid of this 420. I would end up with 2j is equal to, now because I'm making a video, I'm not going to try to do this in my head. If we were in our class, I would. Sorry about that. Okay, so I'm going to do clear all. 3,240 minus 420, which is going to give me 2,820. And then to get j by itself, you're going to divide both sides by 2. And you end up with j equal to 1,410. Let's just double check that. Answer divided by 2. Perfect. I was nervous on a video. I'm going to make a mistake. Okay, so then what you're going to do is you've set up your equation, you've solved it. Now we want to state our solution. So what you're going to always do is take this information and go back up to your let statements. So we've said that James is just J. So 1,410. If you'd let this be X, then it would be really important to know which one's X. And then Maria is that 1,410 plus 420, which is going to give me 1,830. Now, word questions should have word answers. If you do a good job up here and it's really clear what you're solving for, I'll take this. But I want to see that you know what you're solving for. So either it goes up here very clearly, or you write a therefore statement and therefore say that Maria has 1,830 and James 1,410 stamps. And then you just make sure that it's reasonable. So one thing I always check is that these answers don't come out as negative. You can't have a negative number of stamps. And then I always just check the words of the question. So together they have 3,240. If I add these together, do I get 3,240? Yes. Does Maria have 420 more stamps than James? Yes. Then I've solved it. Now, I will also give a disclaimer. Yes, I know you can do this without algebra. I get it. Okay. Lots of people are like, can't you just like minus the 420 and divide by 2 and then know how? And I'm like, yeah, of course. But this is an algebra course. So they're giving you an example. It's not the best example, but they're giving you an example that you can set up as a linear equation. And so they want you to. They want to see, and they being the people who write the articulation guide and decide what skills you need to go on to the next level, they want to see that you can take the words of a word problem and translate it into an algebraic equation. Yay, we did. Okay, now we're just going to practice this type twice more until you're feeling super confident with it. So let's look at the next question. For the 2024 NHL season, the top goal scorers were Connor McDavid of the Edmonton Oilers and Auston Matthews of the Toronto Maple Leafs. These two players had a total of 92 goals. Oh, look, total. And Matthews had 8 fewer goals than McDavid. How many goals did each player score? So in step 1, I've read the question. I've identified this as one of those total word problems. And then I know that the two things I'm solving for are the number of goals by McDavid and Matthews. This used to be a baseball example, but I have a really big hockey kid. So I was like, I should make it hockey. All right. Then what we're going to do is we're going to write one of these as a variable and one of these in terms of the other. So this says that Matthews had 8 fewer goals than McDavid. Now, they both start with an M. So if I was to assign a variable, I'm going to probably assign McDavid a D, or I could give him a C for Connor, right? So McDavid is going to be D, and then Matthews had 8 fewer goals than McDavid. That's step 1 and 2. Step 3, we're going to set up our equation. We know that the total number of goals was 92. The number of goals by McDavid and the total goals by Matthews, which you do not need to write the step if you don't need it, is going to equal 92. Now McDavid, we're letting be D, and Matthews is D minus 8. And then you're going to solve it. So I'm going to combine like terms. I end up with 2D minus 8 is equal to 92. Then I'm going to add 8 to each side. I end up with 2D is equal to 100. Then I'm going to divide both sides by 2, and I get D is equal to 50. Then always, 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 when you're solving these, take this answer and go back up. Now I know that McDavid scored 50 and Matthews scored 50 minus 8, which is 42. And again, totally okay with this as long as you do a good job of clearly showing your answers, or follow the rule that word questions get word answers. So therefore, McDavid scored 50 and Matthew's 42, that is not a 4, 42 goals. Yay. Now these should start feeling repetitive. We used to do more similar type questions to this, but I was like, let's just make word problems feel accessible. So this is going to be wash and repeat. We have one more question. I want you to pause the video and give this one a go. This one is talking about going to a concert. Emma and her friend Liam went to a concert. Together, they spent $350 on tickets. Liam paid $50 less for his ticket than Emma. See if you can set up this word problem and solve. Pause the video. Okay, so we've got, now this is, I'm going to do like mine. I just go Liam and Emma, right? If you want to be more descriptive, so this would be ticket price for Liam and Emma. Now, this is a together question, so it's going to be one of these totals, but Liam paid $50 less than Emma. So I'm going to let Emma be E, and I'm going to say Liam paid $50 less. Wow, how expensive was this concert? Now together they spent $350. So Liam plus Emma came to $350. Yes, I know you can solve this without an equation. We're practicing setting up equations. I could make these harder, right? If people start solving these without algebra, all I have to do is make the questions harder so that you can't solve them without algebra. But I don't want to do that. So just treat them as a gift. Liam is Emma minus 50. Emma is Emma. All right, collect like terms. 2e minus 50 is equal to 350. Add 50 to each side. 2 of Emma is equal to 400. Divide by 2 means that Emma spent $200. So then you're going to take this, boom, plug it back in. You end up saying that Emma spent 200 and Liam spent 200 minus 50 or 150. So therefore, Liam spent 150 and Emma 200. All right, this is the end of the first type of word problem. Hopefully this feels okay. And again, yes, these are straightforward questions because I want you to learn how to set up a word problem. And then all we are going to do is make these more complicated. But your process isn't going to change, so they're not going to feel that much harder. Get the process down pat, and I promise these will be okay. If these are freaking you out, practice a ton, right? Till you're like, oh, every single question looks like this. And then they'll just start feeling repetitive. I always say when things start feeling repetitive, you've done enough practice. All right, good luck.